Here's an example. Julia drives a dump truck hauling rock. The truck holds 3/10 tons of rock in each load. If there's 4/7 total tons of rock, how many loads are there? This is an interesting question. Now, sometimes when you read difficult questions like this and you're not sure, like, what am I even supposed to do? I'm supposed to add, subtract, multiply, divide those fractions. What am I supposed to do? One thing I've seen over the years helps me and my students as well, is if you just put in nice, easy numbers. Like, what if it said the truck holds, I don't know, 2 tons of rocks? Just make that easy number. And if there is a total of 10 total tons. What if we said the truck holds 2 tons of rocks in each load, and there's a total of 10 tons of rocks? How many loads? You would know what to do right away. You'd go 5 loads. 5 loads, right? The truck can hold 2 loads. Yeah, 2 loads, 2 tons, 2 tons for each load. And there's a total of 10 tons, so 5, right? You'd be right. And think about what you're doing with those numbers. You're taking this number, if it was 10, and you're dividing by this number, 2, and getting the answer 5, right? That would be exactly the correct thing to do. So, do the same thing with the 4/7 and the 3/10, right? Track it over here. 4/7 divided by this number. Track it over here. 3/10. It's the exact same deal. It's just uglier numbers. Do you see how you think better with easier numbers? So that's a strategy. I hope you'll make note of that in your mind. When you read a difficult word problem, you're going to go on and take higher math classes than this one to get your your multiple subject credential. You're going to take Math 10B and then a higher one, Math 100, which is harder, definitely more difficult word problems. And you want to teach kids to handle word problems as well. So a good strategy is when you read a difficult word problem and they got some weird numbers in there, put in really easy numbers, and you'll think better. It'll like clear up your head a little bit. And then you go, oh, I just divide. I just take this number and divide by that number. Right. So do that with the ugly fractions. Okay, here we go. Now, how do you divide 2 fractions? Do you remember? You have to actually take the first one and you change to multiply and you flip this one. Some people call it keep, change, flip. Meaning I kept the first fraction the same. I changed to from dividing to multiplication, keep, change, flip, and I flipped the last fraction. So keep, change, flip. Now why? Why are we doing keep, change, flip? It's because dividing is upside down multiplication. You know that, right? I don't want this to just be some weird math trick. Keep, change, flip. Keep, change, flip. I mean, that's good. It's good to have shortcut words and stuff, but in the end, math is about understanding, and I hope you'll communicate that way to younger folks that you teach. And so I would show them why this is true by thinking about an example. I would say, well, you know that 10 divided by 2 is 5, as we just saw, right? Isn't that the same thing as 10 multiplied by a half, right? What's half of 10? 5, same answer. Do you see how dividing by 2 is the same as multiplying by the upside down? Right. See, take something they already know and help them to pause, observe, and think about what they already know. Dividing is upside down multiplying. Dividing by a number, same as multiplying by the upside down. So that's what we just did. We changed from dividing to multiplying by the upside down. Dividing is upside down multiplying. All right, now we can do it. All right, keep, change, flip also works. So how do we do it? Well, we multiply straight, don't we? We just go straight. 4 times 10, 3 times 7. 4 times 10 is 40. 3 times 7 is 21. You can't reduce that. Nothing goes into 40 and 21. So that's it. 40, 21. How many total loads? 40 over 21, which really is just under 2 loads. That's just, that the answer to that will be just under 2 loads. I'm going to leave it as 40 over 21. If it bugs you, that's just, if you divide that in your calculator, it's 1.9. Here, I'll do it on my calculator. Real quick to get an answer. It's 1.9, 1.9 0.04, blah, blah, blah. It's about 1.9. It's just under 2 loads. So in other words, we can get all those rocks moved in 2 loads because that's just under 2 loads. But we're leaving it as a fraction because this is the fraction section. There we go.